About tutoring, two opportunities here: student support services and the Space Center. Student support services on this level, Space Center down on the first floor. And they're almost right above one another, you know, and below one another, just on opposite sides of the hall. So they're right there. And on the Birmingham campus, you've got both of those, plus the STEM Center that has tutoring as well. So take advantage of it. It's there. I guess those are major announcements. And this one, okay, almost seems like more the exception than the rule now. It should have been the rule all along, but it just didn't work. Courtney, right? Yeah. Normally, I'm supposed to have office hours on Friday on the Birmingham campus from 7:45 to 11:45. Okay? Last week, I had a doctor's appointment. The week before that, I had an infusion. The week before that, I had professional meetings. The week before that, I think I was there. And then 3 weeks before that, I had infusions. So, been a while. One time in the last month and a half that I've been there. But this Friday, day after tomorrow, I should be there. However, they've called a meeting at 8:30, and it'll go at least till 9:30. I imagine later than that. And we have to be there by 8:15, though. I don't know why, but we have to be there 15 minutes early. So I'll be in the office from 7:45 to 8:15. Then I'll be in a meeting until probably 9:45-ish or so, maybe 10. But then I'll be back in the office till at least 11:45. So you can catch me early or catch me on the late side of morning, but in the middle, in a required, absolutely mandatory meeting to be. All right, any questions on anything we've done so far? And awfully sorry. Let's talk about this a little bit too. You know, we've got to get so far to go in the term and to cover material. We've just lost one day early in the term and then this time. Do you think we need to do anything to make up a day? Like maybe meeting early for a few days to try to make up the material, or you think we'll be able to cram it in with what time we've got left? What do you feel? Could any of you come, say, a little early? I don't have anything after 10:45, so I could come rather than at 2. We could do 1:30 for, say, 3 days, and that would cover it. It's up to you. What do you think? Do you think you? Say again?
I said I can come. I need to be.
You think so? Okay. So do you want to? I can't stay late today because I've got a class on the Birmingham campus. That's why I was trying to get everything done I could beforehand, because a couple of times I've been just barely getting there in time. So after spring break, that first week after spring break, and then Monday of the next week to start. Does that sound okay to you? 30 minutes early, 1:30 rather than 2? Okay, and that way we might get caught up a little bit. Okay?
Could you send us a reminder? Send us a reminder text.
Oh yeah, that's right, because that will be your first day back from spring break. I'll try to do that. I can't always guarantee I can get internet access because we're going to be out of town over spring break. So I can't guarantee I'll have internet access, but I usually do. So I'll try to give it a shot. We have a farm in Georgia, the family does, and so we're going over there to take care of some things, and the wireless out there is very poor. Okay, and sometimes if the wind's blowing or something else, you sometimes just can't get it. It's on the phone line, it's DSL, it's slow and all sorts of things. But if I can do it, I'll try to remember to do that. All right, good deal. Okay, any other questions before we get going? Okay, so let's go from current slide. And this is equivalent to the power rule, using the power rule that's in your text on page 682, but I think what we started doing was just doing the one on the slides so you can see how it works, and then you do the one on the text and in the margin. And if you have any problems with that, we'll go with that. I'll answer any questions on it. So what are we doing? Using the power rule for exponents to simplify. Okay? Now, they even put the rule up here at the top. AB to the nth power is A to the m times B to the m. So, what would you do to this one? 2ABC raised to the 4th power. Let me get my pen activated here. All right, what would that be? Anybody?
16.
Okay, 2 to the 4th, I'm going to write it that way, then I'll come back and write that, times A to the 4th, B to the 4th, C to the 4th. And 2 to the 4th, since we know what that is, it's 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 to the 4th is 16. 16, A to the 4th, B to the 4th, C to the 4th. Now, that's true, absolutely true. The thing that I wonder is, how is that simpler than this? Okay, they say simplify. Yeah, it's fine, but it doesn't really make it look any simpler. In fact, that's a little more complicated looking than that is to me, but they're just having you practice it. Okay? So there is the A. Anyone got a question about it? All right, to erase? No? You still writing? Okay. Next thing I'm going to do is going to come up and do it how they do it. So I think you'll get to see everything. So let me, and if I'm wrong, I'll go write it again, okay? So let's see what they do. They say, there's the power, okay? The 4th power. Let's bring that inside the parentheses. It'll be 2 to the 4th. There, they did it all at once, okay? Times A to the 4th, times B to the 4th, times C to the 4th. And since we know what 2 to the 4th is, 16. And here's the way I really do 2 to the 4th. 2 times 2 is 4. 2 times 2 is 4 times 4 is. It's a little easier than doing each one at a time. But any way you want to do it, okay? So that's their answer. Same thing we got. Everybody got it now? All right. Let's look at the B. Okay. What would this be? You tell me. 5, just 5. That's outside the parentheses, so you don't raise that to any power. Next. X squared. Y to the 6. When you raise a power to a power, coming through the right, you multiply the exponents. So that is a 6. If you're multiplying a power by a power, you add the exponent. Raising a power to a power, you multiply the exponents. That looks like the answer to me right there. Okay? Would it be all right to erase so we can, it'll, I think, do the same thing on the slide. Okay? There's the power, 2. And that'll be 5. Oh, okay. Yeah. 5 times x squared, y to the 6, and then multiply them all through. You didn't really need the parentheses there at all. 5x squared, y to the 6. Same thing we got. They took one extra set of writing for some reason to do it, but it's fine. There's nothing wrong with putting extra steps in if it helps you understand. Any questions on that? Everybody see it? Everybody got it? Okay, let's see if they have a C. Yeah, here we go. Woo boy. Okay. What will this one be? 7. Okay. Times, I'm going to do sort of like they did. 2 to the what? 3rd. Yeah, we'll come back and figure out what it is. M to the third, N to the what? 15th. 5 times 3, 15. P to the 21st. Okay? And then we'll take 2 steps to do it. Texas 2-step here. 7 times 2 to the third is? You said it earlier. 2 to the third? 8 times M cubed N 15 P 21, and then when you multiply those together, what do you get? 7 times 8? 56, right? 56. M cubed N 15th P 21st. Okay. Does everybody see that? Any questions about it? Okay. Using the power rule. Okay. Pretty sure the same thing is going to show up here, so I'll go on and erase this, and then you can continue copying with what they do. There's the power, and that's oh, this time they really got fancy. You raise each of these things in the parentheses to that power, not the 7. The 7's outside the parentheses, okay? So that gives us 7 times 2 to the third times M, M to the 1 to the third, N to the 5th to the third, and P to the 7th to the third. If this helps you see where those numbers came from, use it. Take as many steps as you need. So this will be 7 times 2 cubed will be 8. M to the first. If you don't see an exponent, understand it to be a 1. Cubing that, that would be M times M times M. That's M cubed. Okay? This would be N to the 5th times N to the 5th times N to the 5th. You got 15 of those. 5 times 3. And this would be P to the 7th, P to the 7th, P to the 7th. You got 21 of those. So that's why you raise that to the power. And that would be taking as much time as you need. 7 times 8, M cubed, N to the 15th, P to the 21st. And then multiplying through, you got 56, M cubed, N 15th, P 21st. Make sense? Any questions on it? If you help, say again?
I'm just still writing.
Okay, yeah, okay. I'll leave it. They took a few extra steps. If that helps you see it better, go for it. If you saw it all right beforehand, you can choose whether to take extra steps or not. But there's plenty, we'll provide plenty of paper, okay? Or ask you to, okay? Oh, Greg Joy decided to join us today. And since we have sort of a lull in the action here and more people are in here, I met with some high school and university UAB students on Sunday that were planning the, I don't know if you've heard about it, the, let's see, goodness gracious, I can't remember the name of it now. It's the rally that's coming up this Saturday. It sounds like, yeah, it's Our Lives. It's the one on gun violence. And it's going to be at Railroad Park in downtown Birmingham. And it's going to be, I think, at 2 o'clock in the afternoon. And they'll be marching certain routes. But certain ones of the high school students will be dressed in red to commemorate the 17 of them will be to commemorate the 17 students killed at Parkland. One's going to dress in another color to represent the student killed at Huffman High, and then another one's going to dress in a different color for the nursing supervisor that got shot, in Highlands Hospital just in the last week or so. So that is happening. Y'all are students too. You're certainly welcome to come and join it. My wife told me she signed me up to be a marshal at it, so I'll have the bat. No, I'll be helping to direct traffic. But it's certainly an appropriate thing, I think, these days. There's just too many of these shootings going on. I'm so embarrassed I can't remember the actual name of it. What is the one they have in January every year in Washington, D.C.? Okay. Marching for Our Lives. That's the name of it. Marching for Our Lives, and it's dealing with gun violence. And there were a bunch of adults there, too, that are helping and contributing and that type of thing. So if you can get out there, 2 o'clock Saturday afternoon, and it should be pretty nice weather, I think 70s or so, so it should be quite nice. And Railroad Park's a great place if you've never been there. It's pretty nice. It's on South Side Birmingham, real close to Regent Field, the new baseball field that the Barons play in. All right, here is D. I didn't know they, oh yeah, they have a D in the book too. How are we going to do this one? -3 to the 4th raised to the 5th. Say again? I can't hear. A little. Okay, add the exponents? Not a bad idea, except you don't add them, you multiply them, yeah. If you're multiplying same base, different exponents, you add exponents. When you raise the exponent to an exponent, that's when you multiply. So you could do that, and I'll do it since you said it. That's -3 to the, what would that be then? I thought I heard someone whisper it. 20th, okay? Now, I'm not very good at raising -3 to the 20th power, so I was going to say it this way, because I can do this, and this is another way you could approach it, is -3 to the 4th, then, got my parentheses in the wrong place. I'm just copying it down, so to the 5th. Well, -3 to the 4th is -3 times -3, that would be +9. Well, let's do another -3 times a -3, +9. 9 times 9? 81. So this would be 81 to the 5th. Now, I can't do that one either very easily, not at all in my head, but if you got a calculator that has the exponentiation key and that shows up in several ways on different calculators, so I can help you find it if you have a calculator that you need to know how to do it. 81 to the 5th power. It's going to be some enormous number, okay? I mean, 100,000, million, 10 million, something. It's going to be really, really big, okay? I will be interested to see what they get for it. So I would either leave it in this form, because I can't calculate that in my head either, or in that form. Either one would work. Huh? Yeah, I know. At least 6, 7 digits. Huh? Second?
3 billion.
3 billion, okay.
486,784,401.
Oh, is that it? I should have known that. Okay. So, yeah, huge number. Let's see what they do on the slideshow. Okay, I think both of these, or at least something like this, will come up. Let's see what we get. All right, let's see what they do here. Interesting how they do this. They separate the -1 out from the 3. Then they have the 3 to, and yeah. I do not like the way they've written this, okay? I see what they're saying, that -3 is -1 times 3, and that whole thing is raised to the 4th power. So we'll come back and do that, and then raise it to the 5th power, okay? Let's just see which way they're going. So there's the exponent on the outside. So we're going to do minus 1 to the 5th, 3, no. Well, no. They've got it wrong. I'm sorry. Let's see what they do with it. They have this wrong so far. That's why I said I really don't like this way of doing it. That is totally wrong. And do you see why? Because this negative 1 is also raised to the 4th. It's not. If the parentheses, if the minus was out here and parentheses was 3 to the 4th, this would be the right answer. But since the minus 3 is raised to the 4th, that minus sign is raised to the 4th power as well, and they treated it as if it wasn't. Okay? So this answer is wrong. The one we did was right. Does anyone need to see that again? The only difference is it's plus 3 to the 20th. And that's what we got, right? In one of our answers. 3 to the 20th. On what I did. Yeah, okay. So this minus sign is wrong. Because this minus is raised to the 4th as well as this. When I saw this, I said, I don't like the way it's written because it wasn't clear that that's the truth. And sure enough, they missed it. Okay? Well, let me see. They did it in the book that way too. So maybe I'll retract.
Mr. Fowler, is your way positive 3 instead of negative?
Well, yeah. The way it's written is ambiguous. Okay? Now, I think I understand what they're saying now. Remember the rules of order of operation? Please excuse my dear Aunt Sally. They're doing the exponent before they multiply by minus 1. So doing it that way, that does give you the right answer. So sorry, I was reading that as negative 3 to the 4th power because it's written that way, but...
What is minus 1?
Say again?
The minus 1.
Okay. What they're doing is separating... They're saying, if this was a minus x to the 4th, if that was a variable there, then yeah, that would be, I would have seen that and said, yeah, that's minus x to the 4th. That's a negative number. But we're writing as minus 3 to the 4th. That's not at all clear that it's the negative of 3, the negative of 3 to the 4th. If I was looking at that, I would think that's negative 3 to the 4th. That's what I thought it meant. That's what it usually does. Now, if that was a variable, sure. You know, x is not, can't come with a minus sign. You can put one there. But this looks like the number negative 3. So I will try to avoid one that's ambiguous like this on the test. But what they're saying is a negative 1, it was a negative 3 to the 4th. That you negate this number here. And that's why they said it this way. It's the negative of 3 to the 4th. And looking at that, I would never have guessed that's the case. Because when I see negative 3 to the 4th, I think the whole thing. If that was negative x to the 4th, yes, no question. X to the 4th, and then you negate it. But with that, a 3, negative 3 can be an entity by itself. Okay? And so I don't know. I just don't like, that's ambiguous. I see what they're saying. It can be interpreted that way. Sorry about that. I wish they wouldn't do dumb things like that. Most of the time, if you were trying to do that, I would have put the minus sign out here, okay? And then there's no ambiguity at all. None at all. It'd be negative 3 to the 4th raised to the 5th. Therefore, I don't like writing it in ways that can be interpreted two different ways. Sorry. So they are right in a sense, okay? Now, the power rule B, that's the one that we're talking about, does not apply to a sum. We know this. 5y squared is 5 squared times y squared, because everything's multiplied. But this is not, okay? Because what this means is 5 plus y times 5 plus y times 5 plus, 5 plus y times 5 plus y. That is not the same as 5 squared plus y squared. In fact, we know it's specifically not, because this would be 5 plus y times 5 plus y, and that would be 25. Remember first, FOIL, outer plus 5y, inner plus 5y, last plus y squared. That would be 25 plus 10y plus y squared. Not the same as this, so don't do it. But you know what? I have people in calculus class doing that. You know, you can't do it. It's wrong. If you're adding things inside a power, a sum inside a power, you multiply all the terms out, just like I did here. If you're multiplying things inside a power, yeah, you can raise the powers to just like they did here. But that is not the same. Your sum, the power rule, does not apply to sums. Only applies to products and quotients. Okay? Only products and quotients. Okay? Now, let's do the second one. They're calling this C. Okay? A over B to the M. Yeah, you can do this when you're dividing. It does the same way. That's A to the M divided by B to the M. Okay? For any positive integer M, later we'll see even for negative integers, but that's a whole different thing. So we'll keep it positive now. A over B to the M is A to the M over B to the M. As long as B is not 0, you can't ever divide by 0, not even with the power rule, so don't try it, okay? You raise a quotient to a power by raising both the numerator and the denominator by that power. So this one, 3/4 squared, would be what? 3 squared over 4 squared, which would be? 3 squared is? Over 16, 9/16. They just left it like that. For simple numbers, I'd go on and carry it one more step. Okay? But that's correct. There's nothing wrong with it. Okay? All right. Move on. All right. So let's use example 7. They've got 3 in the book. Let's see if they got 3 here. Use the power rule for exponents to simplify that. What would that be? Help me, help me. 2 to the 4th over 5 to the 4th. Okay? Anyone want to make a stab on what 2 to the 4th is? 16. We've had it before today. Now 5 to the 4th is a little harder, but it should be close enough. 5 times 5 is 25 times 5 again. 125 times 5 again is 625. Yeah, very good. 16 over 625. Now, I doubt if they take it that far, but if you can do it, if you've got a calculator, it'll do it too. Okay? Now, the trouble with calculators, though, they're going to give you a decimal number, and there's no way to recognize that as a decimal number. But with the numerators and the denominators, you can see that's the case. Okay? So, all right, to erase, because it's going to come up with the actual answer, hopefully the same as ours, maybe one step short. Let's see what they do. They did the same thing, didn't they? Very good. Whoa! And then they went on to B. All right, so there was A, just like we did, spread out a little bit, but it's okay. And then what's B? You tell me. Pretty simple. Help me. X to the 7th over y to the 7th. And that's about all you can do, folks. That's about as simple as you can make it. In fact, I think this is just about as simple. Okay? So what I'll do is go on and erase what I just did, and let's see if they did the same thing. Yep, there it is. Oh! Didn't say that, as long as y is not equal to 0. But you know that's true here before you even got to that step. you can never divide by 0. So that should have been part of the original problem. Y can't be equal to 0. Okay? Let's see if they've got a third one here. Everybody got that? Okay? No, they don't. So let's do the third one that's in your text, though it's nothing new. In fact, it's not at all new. Let's do the first one that's in the text. That's, if I can read it, yeah. The first one's in the text. This is the A from the text, and that was 2/3 to the 5th. What would that be? Two to the 5th over 3 to the 5th. Now we did up to 2 to the 4th. Anyone remember what that was? 16. So just multiply by 2 one more time. 32. So that numerator is going to be 32. How about that denominator? Didn't we do already today 3 to the 4th? 3 times 3 is? 9, and 3 times 3 is? And 9 times 9 is? 81. So that's 81. So 81 times 3, 243, right? Okay. So that would be over 243. All right. And let's see what the book got. Yes, 32 over 243. Good for them. Where 3 is not equal to 0. No, I'm just kidding. 3, of course, is never equal to 0. So, again, do the examples in the book. The ones on the slide, for some reason, are different. And do the ones in the margin. They have the answers for the margin there, too.
What page is that?
That's what we did before was for 862. This is 863. And also on 863, can I move on, or are you still writing? Got it. Okay. Here are rules for exponents. This is putting them all together, kind of. For any positive integers, m and n, these are going to be your exponents. So keep them positive and keep them integers. No fractions, no decimals, no rational or irrational, positive integers. Okay? If you're multiplying same base, different exponents, or even if they're same exponents, keep the base, add the exponents. Okay? Example here, 3 to the 4th times 3 to the 5th is what? 3 to the 9th. Okay, very good. Because this would be 3 times 3 times 3 times 3, 4 3s here, 5 3s there, multiple them together, you come up with 9 3s, 9 factors of 3. And then the power rules, that's the product rule. The power rules, the simple one is base raised to a power, but then raise that to a power. That'd be a to the m times a to the m times a to the m times a to the m. You know, so you have am times, am times, am times. You multiply the exponents. Keep the base, multiply the exponent. So 2 to the 4th raised to the 5th would be 2 to the 20th. And that's too big a number for me to try to guess what it is. Okay? Now, if you have a product inside the parentheses, and you're raising that to a power, and now remember this product, either one of those could have exponents, so keep that in mind too. That would be a to the m times b to the m, because everything's multiplied here. This is ab times ab times ab times ab m times, so it would be a to the m times b to the m. So what would this one be? 4 to the 3rd? K cubed. Very good. And what is 4 to the 3rd? Anyone know that one? $64. Perfect. 4 times 4 is 16. Times another 4 is 64. So you could have written that one 64a cubed. Okay? K cubed. This is a over b raised to the m. The third one we did, that's a to the m over b to the m. Perfect. And what would this one be? Over 7 to the 3rd. 4 to the 3rd was 64. 7 to the third, that's quite a bit harder. So let's leave that one alone. Okay? It'd be 49 times 7, which that's doable, but yeah, second.
343.
Okay, good deal. Now, of course, anytime you have any number in the denominator, if that's a variable, that variable can't be 0. Ever. Okay, so don't ever assume or put one in that is. Okay, so the next objective in this section is to use combinations of these rules for exponents. So that's what's coming up next. Okay, now that doesn't look... Oh, okay. I thought that was an equal sign there. I said, how did they get that? No. This is this one times that. Okay. So how would you do that? 3 to the 3 squared over 4 squared times 3 to the 5th. Okay. Now that 3 to the 5th you could put over 1. So now we can deal with the numerators alone, because this is multiplication. What would that be? 3 to the, a little louder, 7 over 4 squared. Okay, because there's nothing multiplied by the denominator. So I'm not about to figure out what 3 to the 7th is. 3 to the 7th over, and what's 4 squared? 16, yeah. Now that's dumb to put it that way, but just to get you used to doing your squares. Okay? And 3 to the 7th you could do, that would be 3 times 3 is 9. 9 times, another 3 times 3, that would be 4 threes, that would be 81. And another 3, you just get to be too big a number. Okay? So they probably left it like this right here. 3 to the 7th over 4 squared. Let's see. All right. They first do 3 squared over 4 squared times, and they even put it over 1. Good for them. 3 to the 5th times 1. Then you can do the numerators. This is how you multiply fractions, is multiply numerator by numerator, denominator by denominator. But that numerator is is same base, different exponents, multiplied together, keep the base, 3, add the exponents, 7, and leave that over 4 squared. And I think that's how they leave it, right? Anyone need it a little longer? They didn't take it the one more step, which is just as good. Got it? Okay, everybody? Okay. Well, I hit the button and nothing happened. Oh, there we go. Here's the B part. All right, what are we going to do here? Now that 5 is right next to the parentheses. It doesn't look like it is, but it is. What would this be? There's actually a couple, maybe more than 2 ways you could approach this one. You decide. Say again? Okay, a little louder, I think. One more time. Okay, there's not really any terms here, because terms are things separated by plus or minus signs. I think I know what you're saying. You add together like bases that are raised to powers, okay? So you tell me what you meant by that. What would be a result of what you just said? Okay, I heard of 49. What was the next thing you said? Okay, 49 what? Oh, M? Okay, M to the 4th, you said? Yeah. And N to the 2nd. Okay, that's all right. Raise. Okay. I think I see what you're doing, but okay. Hold off on that for a minute. Okay. Now, one thing I think he's seeing is this is the same base as that, right? This is same base multiplied together with different exponents. What would you do? There's at least two ways to do this. The way I think he's saying is keep the base, which is 7m squared n, and do what to the exponents? Add them. Okay? So here's one way to do this. I don't know if this is what you meant, but it would be 7m squared n to the 8th. And then take that and make it what? Now use the power rule. Second? 7 to the 8th, m to the 16th, n to the 8th. That is certainly one way to do it. But what I think I heard him saying was multiply these two together and raise the exponent. Don't do that. Keep the base just like it is, add the exponent. Okay? And here's the other way you could have done this, and this is perfectly fine too. You could have done each piece by itself. 7 cubed, m to the what? 6th, n to the 3rd, times 7 5th, m to the what? 10th, n to the 5th, okay? And then you can multiply these, but again, when you multiply, don't multiply the numbers, keep the bases, add the exponents. You see, the exponents are doing the work for you there, and you don't have to multiply. If I can get my pen back. That would be 7 to the 8th, m to the 16th, oops, wrote it in the wrong place, n to the 8th. And that's exactly what we got here. So either way would do it. You can either raise this base to that power, raise this base to that power, and then combine. Took it, that's what you meant by combining like terms. They're not terms, but combining the things together that are the same. But don't multiply them. Let the exponents do the multiplying for you. I think it was a little simpler in this case to recognize this base was exactly the same as that base. So then you could just take that as the base and add your exponents, and then do the product rule for exponents. That, to me, is a little bit clearer if you recognize that. Now, what you have to be careful for, 7m squared n to the 3rd times 7m n squared to the 5th, those are not the same bases. Then you would do it the way we did down here. They have to be identically the same bases. What's inside the parentheses have to be precisely the same thing before you can add the exponents. Okay.
Mr. Fowler, can you show me 7 to the 8th? I see the 16 and I see the 8, but I'm trying to see, is it 1? Is it where's the 1?
Okay. Are you on the top row or down here?
Yes, the last row, right here.
Down here?
Yes, sir.
Okay. Okay, here's what we did. That's how we got from here to there. Is 7 to the 3rd, m squared to the 3rd, which is m to the 6th, n to the 3rd, times, you don't see the time sign, but I'll put the time sign there. 7 to the 5th, that's a 5, it's an ugly 5, but it is. M squared to the 5th, which is multiply the exponents, m to the 10th, n to the 5th. Okay? Now we take the similar numbers, 7 cubed, similar bases, 7 cubed times 7 to the 5th, keep the base, add the exponents.
Okay.
Yeah.
Right. Yes, I see the 5 and 3. Okay.
Yeah.
Okay.
Okay, and then the rest of them follow from there.
6 plus 10 is 16, and then 3 plus 5.
Is that again? Yeah. Good deal. Good question. Excellent question. All right. All right. That's how we did it. Let's see which way they did it. I'm pretty sure they did it the first way. But let's take a look. Okay, yeah. They highlighted the bases, including one parentheses but not the other. I don't know. That's just graphics. Okay. So they took that base and added the exponents, kept the base, added the exponents, and that gave them 7m squared n raised to the 8th. Very good. And then they used the product rule with 8 there, 7 to the 8th, m squared to the 8th, which is m to the 16th, times n to the 8th, which is n to the 8th. And that's pretty much sure that's how they leave the answer. Yeah. There's no reason to try to raise 7 to the 8th power. Ugh. That's an enormous number. 7 times 7 would be 49. 7 times 7 would be 8 times 49. Times another 7 times 7 is another 49. Times another 7 times 7 is another 49. That would be close to 50 times 50 times 50 times 50. Huge, 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 huge number. So yeah, leave that alone. Leave it at 7 to the 8th. Okay.
It just seems so much simpler their way.
Well, that's the way we did it first. Yeah. But then I showed you the other way you could do it, but I wasn't recommending you did. Okay? What's that? Is there more? Okay. Was that B? Yeah, I guess it was. Yeah, there was A. Okay. Here is C. All right, what are we going to do here? Any suggestions?
Distribute the exponent.
What's that?
Distribute it.
Okay, say that one more time.
Distribute the exponent. Do the 6.
Yeah, just deal with the exponents. Yeah, these are not the same basis, so we can't do the same thing we did before. Okay? So what would this be? 2 to the 6th. X to the 18th. It's x cubed raised to the 6th power. That's x cubed times x cubed times x. 6 times 3 is 18. Y to the 6th times 2 to the 10th. How much? 70th. Oh, these are even big numbers writing. Okay, and y to the 40th. Okay, I love these, don't you? Okay, what would this be? To the 16th. Now, same basis multiplied, add the exponents. X to the 88th, okay, to the 46th. All right, good deal. Okay. Everybody see that? Powers raised to a power, you multiply exponents. 1 times 6 is 6, 3 times 6 is 18, 1 times 6 is 6. When you're raising a power to a power, same thing here. 2 to the 10th, 1 times 10 is 10, 7 times 10 is 70, 4 times 10 is 40. And then once you're just multiplying things out, same basis, multiply together. 6 plus 10 is 16, 18 plus 70 is 88, and 6 plus 40 is 46. So that's what we got. Let's see what they got. Okay. Yep, looks like they did the same thing. They just wrote them out one more step in there. 2 to the 6th, x cubed to the 6th, y to the 6th, 2 to the 10th, x 7th to the 10th, and y 4th to the 10th. Okay? And next they're going to bring inside, so 2 to the 6 stays to the 6, but they probably lose the parentheses. Oh, okay. And then x cubed to the 6 would be x to the 18th. Y first to the 6 would be y to the 6. 2 to the 10th. X to the 7 times 10 is 70. And y to the 4 times 10 is 40. Then, okay, what they're saying is the commutative and associative properties. Okay, commutative means you can change the order you're multiplying, and associative is how you group them together. So we're going to do the 2 to the 6 times 2 to the 10th, bring those together. X to the 18th times x to the 70th, bring those together. Y to the 6th times y to the 40th, brings those together. And let's see, will they put an extra step in there, or will they do it just from here? They did it just from here. I thought maybe they would put these in parentheses, those in parentheses. Yeah, but 2 to the 6 plus 10 is 16. X to the 18 plus 70 is 88. Y to the 6 plus 40 is 46. And then, do they do one more step, taking out the times sign? I don't think so. No. Okay. That is their answer. Okay? Does that make sense? Does? Okay. Anyone still? Okay, some still writing. Okay. Everybody got it? All right. That was C. Let's see. Now the book has a D. Let's see if they do. Yes, they do. So what are we going to do here? Now, remember, with numbers it's ambiguous, but with letters it's not. That's a minus G cubed. That's really obvious. G raised to the third power, multiplied by H, then you negate it. Okay? So don't think that's negative G cubed. For that to be the case, you have to put it in parentheses, because this is a sign in front of this. You do the exponentiation first. Okay, so that's just a negative value squared. Okay? Okay. Now, when you square a negative, what do you get? A positive. So the sign gets squared. You can think of that as a minus 1 squared, which is positive 1. And G squared, G cubed squared is second, G to the 6th power, H squared. Okay, that's that one. Now, when you take a negative 1 and cube it, what do you get? A negative. So that negative, it's not the same negative, but that negative stays negative. And then G to the 6th, H to the what? 15th. Very good. Okay. Now we can multiply these together. Plus times minus is negative. Next, G6 times G6 is, and if you need to, do this, like they did in the book. Okay, I got the negative there. G6 times G6, I can't write, times H squared times 8H to the 15th. Like I said, I can't write. That would be a minus what? G6 times G6 is G to the 12th. That's a 6. No, that's a 2. Okay. H to the 17th. Perfect. Way to go. Okay? Let's see if they got it perfect. Way to go. All right, to erase? Because I think that what they did do is going to be the same thing. So let's make sure. Let's erase and see what they get. All right. They put them in different colors because they're different bases. Okay. So what did they do next? They took the color off. Nice. That's where we started. All right. And they put a -1 there for that negative and a -1 over there for the negative. G cubed H squared G squared H fifth cubed. Okay, the -1 is in there. So that's going to be raising everything in there to those powers. This is going to be -1 squared G, oh yeah, they did it right. They were putting extra stuff in here, now they're not. G, 3 times 2 is 6, H squared. Got it. Times -1 to the cube, we'll come back and see what that is in a minute. G to the 6th, G squared cubed is 6, and H to the 5th to the 3rd is H to the 15th. So they did combine a couple steps there. Now we're going to look at each similar base with different exponents to do. Let's see how they do. Now what I did was going to say -1 squared is +1. And -1 cubed is negative. But they went on and did -1 to the 5th, which is perfectly true. And what is -1 to the 5th? Okay, any negative is -1. Yeah, so there's no reason to do it 5 times. If you did that and know it's a +1, that's going to be a -1. It just is -1. That is a -1. And then it's G, and notice they didn't bring them together. G6 times G6 is G12, and H that's H to the 17th. So all they got to do now is -1 to the 5th. What is -1 to the 5th? Oh, wow. Okay. They're doing each set now. Okay. And then the H's. Yep. Just like we said. That is equal to -G12 H17. Which, let's see if they write it one more way. No, they didn't. Let me go back here and show you one more step you can do. Okay. Right here. And you can leave off the 1 and just make it -G to the 12th, H to the 17th. I don't know if I did that before, but we can do it. There's no reason to write a -1 coefficient. You can just put the minus in front. That's how we started, right? So to me, it seems like that makes sense here. But it's not wrong to do it this way. It's perfectly okay. All right, any questions? Anyone still getting it? Okay. So let's move to example 9. This objective is use the rules for exponents in a geometry problem. Okay. Now this is a different geometry problem from the one in the text, but it's just as good. It says find a polynomial that represents the area of that geometric figure. This is a rectangle. See that little square in the corner? That indicates that's a rectangle, and then the other sides are parallel to each other. So that's a, and by the way, rectangle, that means right angles. Every one of these is a right angle. That's what makes a rectangle a rectangle. Every angle is a right angle. Okay? And what is the area of a rectangle? What's the formula for it? Say again? Length times width, is that what you said? Perfect. And what's the length on this, they tell you? So, area is equal to length times width. That would be 4x cubed is the length times 2x squared of the width, and that would be what? 8 x to the 5th. Perfect. Done. Find the polynomial that represents the area of that geometric figure. That's 8x to the 5th. Right? That seems way too easy. Let's see if they'll give us another one. Okay? I'll go on and erase this because they're going to give their answer too. So the area of the rectangle, they do capital L and capital W. That's fine. That's 4x cubed times 2x squared, 8x to the 5th, product rule. Done. Okay? So there's their answer, 8x to the 5th. Anybody still writing? Got it? Okay. So let's do the B one. And that's find the polynomial that represents the area of this geometric figure. This is a triangle. Does anyone know what the area of a triangle is? That's the perimeter of a triangle.
A squared plus B squared equals C squared.
It's what?
A squared plus B squared equals C squared.
Okay. Now you're given Pythagorean theorem. Okay, all giving true things, but it's not area. What's the area of a triangle? It's 1/2 the base times the height. I don't know why they say length. Usually it's base times height. Okay, now here's why. Okay, this will be a little bizarre, but it's true. If you were to take this blue triangle here and flip it across this long line here, okay? Flip it across there, okay? That puts this up here. I don't draw straight lines very well. This length here gets multiplied, gets flipped there, and this there. Does that sort of look like I flipped it over there? You can, stretching your imagination, sort of guess that to be the case, right? Now the next thing I'm going to do is chop off this little rectangle here where that dotted line is and plug it in right here. Just pick it up here, chop it off, get my scissors, cut it off, and move it here, right? And then what do you have? A rectangle, which is length times width, right? Length times width. This is your width then, okay? But that was exactly twice what this was, so take half of it. So it's 1/2 the length times the width, or 1/2 the base times the height. That's how I usually see it. It's 1/2 base times height. Where this is the height, and this is the base. The whole length here is the base. Okay? So, what would our formula be? A would equal 1/2. What was the length? 8n to the 5th times the width, or I like height better. What's that? Not that hard. 3n to the 4th. And then, I don't like having fractions if I can get rid of them. So 2 will go into 8 4 times. And then, you've got 4 times 3 is? 4 times 3 is? 12. N to the 5th times n to the 4th is? N to the what? 9th, is that what you said? All right, good deal. 12 n to the 9th. Feel like a dentist up here pulling teeth, but I think I got you all to say it. Okay. Let's see what they got. Okay. We'll erase all that. It's chicken scratch. And they do 1/2, 3n to the 4th. I would never have put that for the L. I would have put that for the W. But it doesn't matter. That's commutative. Times 8n to the 5th. That's fine. And that would give you 1/2 of, they multiplied first, 24n to the 9th. And that gave you 12 into the ninth, which is the same thing we got. So it doesn't matter the order you multiply, which way you do it, just follow all the rules. Into the fourth times into the fifth is into the ninth. Keep the base, add the exponents. All right. Any questions on that? All right. That was the last slide in the set. Homework exercises in 13.2 will be do number any of 1 through 4. I think 5 and 6 too. Any of the 7 through 11. I'm sorry, 7 through 12. Any of the ones 13 through 20. Any of the ones 21 to 36, and this is, by the way, on page 865. Any of the ones 37 to 52. Nope, 37 to 60. Okay. Then any of the ones 61 through 82. All right. Now, there's a couple, 83 and 84, are concept checks which are incorrect, and they say they are, and you figure them out. So I really don't like those as much, but if you're helpful for you, do them. Then 85 through 88 you can do. And we'll begin next time with 13.3. All right? We're going a bit more slowly in this section because it's, I think, a little newer for you. It seems like it is anyway. Let's see. Sad news, folks. Good news, bad news. Good news, next week is spring break, but that means we won't see each other for a whole week. So get over it. Okay. Have a good spring break. And be welcome to come Saturday, Railroad Park.